Have you ever wondered if a particle, like an electron, could just pass through a wall as if it weren't there? This isn't a scene from a science fiction movie, but a real-life phenomenon known as quantum tunneling. And if we add the complexity of fractal pathways into the mix, we find ourselves on the precipice of a quantum revolution, all thanks to the McGinty Equation. Imagine a ball rolling up a hill. In our everyday world, if the ball doesn't have enough energy, it won't make it over the hill. But in the quantum world, things work a little differently. A particle, like an electron, can pass right through that hill or barrier, even if it doesn't have enough energy. That's quantum tunneling in a nutshell. But here's where things get really interesting. Picture that hill or barrier as a complex, self-repeating pattern, a fractal. Fractals are everywhere in nature, in snowflakes, ferns, even coastlines. They're irregular yet infinitely complex, with the same pattern repeating over and over at different scales. The McGinty Equation suggests that these fractal pathways could have a profound impact on how particles tunnel, potentially altering the probability distributions and energy landscapes associated with these tunneling events. Scientists are hard at work trying to observe these phenomena. They're using techniques like scanning tunneling microscopy, cold atom experiments, and tunneling spectroscopy, manipulating parameters like barrier height, barrier width, and particle energy. They're looking for deviations in tunneling characteristics that could indicate the presence of fractal-induced effects. So what does all this mean? If the McGinty Equation holds true and fractal pathways do influence quantum tunneling, the implications are mind-boggling. It would revolutionize our understanding of quantum mechanics and particle behavior. It could provide new insights into the dynamics of quantum systems and the role of geometry in shaping their behavior. But it's not just about theoretical understanding. If we can understand how fractal geometry influences quantum tunneling, it could open up new possibilities in fields like nanotechnology, quantum computing, and material science. We could design new materials with tailored electronic properties, or develop new technologies for manipulating and transporting quantum information. In essence, the McGinty Equation and the concept of fractal pathways in quantum tunneling could herald a new era in our understanding of the quantum world. By comparing experimental data with theoretical predictions, we're not just observing the quantum world, we're beginning to understand it and potentially change it. Quantum tunneling via fractal pathways isn't just a theory, it's a potential gateway to a new understanding of our universe.